This tutorial is an overview of Exotherm version 10. The icon for Exotherm version 10 is this one here with a 10. And when you click on it, you would get a form that appears. And this form is the Exotherm ignition form. And from it, you will launch all the various sub-programs of the suite of programs of the Exotherm model. Usually in a certain folder, all the project files would be put together, all the data files or the output files, and you can choose to work with a particular folder by default, and that folder name is here, and you can browse to select a particular folder, or you can choose to, for example, drag and drop from Explorer a different folder. For example, if I would get Explorer up here, I can say drag and drop the samples folder. I can take a data file, any data file in this folder, and drag it to here, and it will show up as a information that you can use the parent folder and say, okay, that is the parent folder. So we can identify which is our working folder, our project folder, from this drag and drop in this box here. Given that folder, we have the various data input programs. This is a program that allows us to transform an Eclipse generated ASCII data file into a format that Exotherm can read and understand. So when you click on that, you will get a form, and from that form you can specify the Eclipse data file, and then you can transform that data file and save it as an Exotherm data file. Very simple. So just open it, and then open, if you have a well completion file, open that next, then open well connection file next, then save it to Exotherm data file, and then exit. Very simple. Digitize Maps is a program that allows us to digitize contour maps. For example, a contour map, and we can digitize structure maps, porosity maps, thickness maps, and then save that as a digitized contour file, which then can be used to create a grid model for simulation. So that would be the WinDig program. Historical data input program allows us to enter historical data, and for Exotherm, the 3 file formats is in this program. It's a general program used for our other simulator Exodus as well. But the one for Exotherm that we have to use is the user-defined format history. Use this one for Exotherm. Use this one only for Exotherm. And you have the ability to enter any columns of data that you want to use. You can specify a decimal date or a year month date. If you're going to use the decimal date, you can say yes to this question, and then you can also put in your data in whatever column you wish to say. For example, oil rate is in the meter cubes per day. Steam rate could be, you can put it in any order. Steam rate in meter cubes per day, and so on. And then you can enter this data and save it for each well number or well name, and save it to a file in a user-defined historical data format that you can then use in the Exotherm preprocessor to use as the rate control, and also use it for matching the history of those specified wells here. So that is a general quick look at the historical well data. And then once we got historical well data, we can look at the preprocessor. Preprocessor allows us to create new grids, input the data into the grids, and the PVT, relative firm, sourcing terms, discretized well bore terms, well flow data, and then we can save that to a file, data file, and then come back to it again, modify it again, save it again. So this has options to open, modify, and save data files. This is the main pre-processing engine of Exotherm, and this must create a complete data file before you can run the simulator. So once you have completed a data set with no errors, you can then execute Exotherm. And when you execute Exotherm, you come up with this form here. In this form, you can specify the data files you want to run. This is just a general overview, so I'm not going to spend very much time on details of each menu item, just to show you that the general capability of these programs. We can specify two or more cases to run, and then if we specify those cases, we can see them listed, and then we can start execution. And when it runs, this is a very small run, so it runs very quickly. It runs two cases at the same time in this case here. And once it's run, you can look at the monitor run status of a selected case. We know it's done 100%, but this is to show the run status. The run status is, for this case here, 100% done. So Exotherm has a capability to show the status of an executed file. Then after it's been run, you want to look at the graphs, and we have two options here. We got two types of charting. We have an older one and a newer one introduced in version 10. In version 10, we have a nicer, we hope, charting facility, but we kept the old version 9 available in case there's some compatibility issues that the user wants to keep the old graphs for continuation of an existing project before he changes to a newer version of version 10 well charts. So in well charts extract, version 10, much like the version 9, you would define assign files, select the files that we have run in this project case. So this is a project case. We can choose a case here and a case here and open it. Sorry, this is select another case here, case 2. So we have two files that we can compare. Process information, view standard graphs, show graphs for steam recovery. I'm just going very quickly here just to show you the general capability of the program, and view and select graphs. And we can see that we have graphs built and selected here, and we can have multiple graphs. We can choose multiple graphs. We can graph another case here, the multiple graphs. So this is the graphing capability of the program, and then we can also have the tabular output in well report utility. In well report utility, we can choose to open run files, and for those we can create tables of well output by well, by time, by parameter. And for example here, well 2, I can choose to have the liquid production for the well for all times, and that will show me that report, or I can add additional reports. For example, the gas, the steam production rate or temperature, and it will show me this well report utility, that these tables of numbers can then be copied over or graph to a report or to Excel. And this Digitize Map report shows you the report utility for the wellbore segments, if you so choose to describe the wells as fluid-filled segments, flowing segments. 2D, 3D display utility shows the run in the pressure, temperature, saturations in the grid cell well. So if, for example, temperature at a particular time, we show you the temperature of the cells at that time. You can animate that and see the temperature profile with time, and you can graph that with time and get reports on selected regions of the model. So that's a utility for showing you the grid cell values. And then this is the documentation which you can browse and print out. This is the PDF file documentation. And finally, you just exit from the program. Thank you for using Exotherm.